You know, every single time you share a photo, send an email, or pull up a file, you're placing your trust in the cloud. You're trusting it to keep your stuff safe. But have you ever wondered what's actually protecting your data from, well, everyone else using that same server? Today, we're going to dive into a tool called NYX. It's a revolutionary bug hunter that's reinforcing the very foundation of cloud security. And believe me, it's making the digital world a whole lot safer for all of us. But before we get into the nitty-gritty, let me ask you something. Just think about all your data floating around in the cloud. Your pictures, your messages, your documents. What is the one single invisible wall that stands between your information and everyone else's, all sitting on the exact same piece of hardware? So, that answer? It's the absolute key to understanding how cloud security even works. It's a concept we can think of as the cloud's invisible wall, and it's all powered by a piece of software that is, without a doubt, one of the most important in all of modern computing. Okay, so that wall, it's called a hypervisor. Now, the easiest way to wrap your head around it is to think of it like the manager of a giant, super secure apartment building. Each tenant, or in this case, a virtual machine, gets their own totally separate apartment. The hypervisor's one job is to make sure your walls are soundproof and your door is locked. It ensures you're completely isolated from all your neighbors. It is the most critical security boundary there is, period. And this is where it gets really serious. A single tiny flaw in that hypervisor, well, it's like handing an attacker a master key to the entire building. They can pull off something called a VM escape, where they literally break out of their own apartment and can then waltz into anybody else's. I mean, the fallout from that is just catastrophic. So, obviously, this means we have to find these flaws before the bad guys do. But trying to hunt for these digital ghosts inside such incredibly complex software, that is a massive challenge. The main way we do this is with a technique called fuzzing. And in the simplest terms, fuzzing is just automatically chucking millions, even billions of different inputs and test cases at a piece of software, basically just to see what makes it break. You're just shaking it until something falls off. But this leads us to a classic problem, a real dilemma for security researchers. On one side, you have blind fuzzing. It's incredibly fast, right? Think of it like a machine that just rattles every single doorknob in that apartment building at lightning speed. But it's dumb. It has no idea what it's doing. On the other side, you've got guided fuzzing. This one is intelligent. It learns from every test it runs and gets smarter as it goes. The huge problem, for something as big and complicated as a hypervisor, it has always been painfully, agonizingly slow. Yeah, for a long, long time, researchers were stuck. You either got speed or you got smarts. You couldn't have both. But that's where our hero, NYX, comes into the picture. This is a totally new breed of hunter. You can really see the whole philosophy behind NYX in this one quote from their paper. Basically, the creators believed that intelligence, what they call coverage guidance, is absolutely worth it. So the goal wasn't to give up on being smart just to be fast. The real challenge was to make the intelligent approach fast enough to actually compete. So how in the world do they pull this off? Well, the core idea is pretty brilliant, and you can see it right here. NYX actually runs the hypervisor it's testing inside its own protective bubble. It's a technique called nested virtualization. This creates this perfect, safe little arena where NYX can throw whatever it wants at the target, watch what happens really carefully, and gather all that precious intelligence without ever risking a crash of the whole system. And this clever setup, it unlocks two secret weapons. Let's talk about the first one, which I like to call the ultimate reset button. It's a solution to one of the biggest headaches in testing complex systems. This amazing feature is called fast snapshots. Just imagine a giant undo button, but for the entire computer. After every single test, it doesn't matter if it was a success or a total crash, NYX can instantly zap the whole virtual machine back to a perfectly clean, pristine state. This is so important because it means every single test is completely isolated and the results are totally reliable. And just look at this chart. The performance gain is, well, it's just staggering. Over on the far left, you see a traditional tool struggling to get maybe one reset done per second. In the middle, you have a really lightweight tool, something like AFL, hitting around 10,000. Now, look at NYX on the right. It is resetting a full virtual machine, a way more complicated task, at about 6,000 times a second. It's bringing the speed of a simple tool to a massive full system problem. Incredible. But look, being fast is only half the battle. NYX is also crazy smart. As you can see here, it all starts with a playbook that a researcher gives it, which basically lays out the rules of the game. From there, NYX generates smart, logical tests, not just a bunch of random garbage. The real secret sauce here is a concept called affine types. Think of it like a super strict grammar checker. It makes sure that every test actually makes sense. That you open a file before you try to read from it, and you don't keep trying to use something after you've already closed it. This intelligence stops NYX from wasting millions of cycles on tests that were just doomed to fail from the start. Okay, so you've got this new hunter that's both ridiculously fast and super smart. What happens when you actually let it loose on real-world software that's already been tested to death? Well, the results are in. Get this. In its initial run, NYX found 44 brand new, never-before-seen security bugs. And we're not talking about some obscure programs nobody uses. These were found in major, widely used hypervisors, like QEMU, which is pretty much the backbone of a huge chunk of the cloud. And out of those 44, 22 of them were serious enough to get official CVE numbers. Now, that's the big leagues. It means these were critical vulnerabilities that get a universal ID so everyone knows about them. Finding and fixing these bugs makes the digital world tangibly, measurably safer for all of us. And it's not just about bagging more bugs, it's about how deep the hunt goes. This table compares how much of the code NYX was able to explore compared to the previous state-of-the-art blind fuzzer. And look, in every single case, from network cards to USB controllers, you can see NYX's intelligent approach let it dig deeper into the code. It wasn't just rattling the same few doorknobs over and over again. It was smart enough to find the secret passages in hidden rooms. And trust me, these were not just some minor glitches. NYX found a Stack Overflow in QEMU where a guest machine could literally crash the entire host server. It found an infinite loop in another hypervisor that could just freeze a server solid. And it found a buffer overflow that could let an attacker write malicious code into protected memory. These are the kinds of serious, high-impact vulnerabilities that keep security teams up at night. So what does this all mean when you zoom out? What's the big takeaway? Well, NYX really proves that in the high-stakes world of bug hunting, intelligence is absolutely king. And with some seriously clever engineering, you don't have to sacrifice speed to get it. Which leaves us with a pretty fascinating thought to end on. Are we stepping into an era where our cybersecurity defenders aren't even human anymore, but fully autonomous programs, constantly hunting, learning, and hardening our digital world faster than any person ever could?